Okay, by my watch, it's time to begin. So we're going to do that because the agenda is ridiculous full. Last meeting, you may recall that we had a pretty light agenda. This time, we were quite surprised by the amount of requests we got. So we're going to keep it moving. Note well, this is the rights, privileges, and most importantly, responsibilities for contributing to the IETF. Please make sure you are aware of these before you do so. Please, please, please be respectful in all your interactions with everybody all the time. And in-person people, please make sure you've logged into the data tracker. This is how we do blue sheets now, so we're not passing anything around. And please, if you're in the room, keep your audio and video inputs turned off. And remote participants, please keep your audio and video off, except when you're chairing or presenting. These are links if you don't know where all the things are. Most importantly is the agenda. Based on the number of requests for speaking slots that we got, we're hoping we can get through all of them. But the question is, should we be planning a virtual interim? The chairs think we should. If there's anybody who thinks that's the wrong way, please speak now. Okay, so we will be starting a doodle for a good time. Yes, Jeff.
Jeff Houston, might I remind the chairs, A, the world is actually a spheroid. Well, it's not quite, but close enough. And the sun is only on one side at any time. So once we get into these virtual meeting systems, some poor bastard has a 3 o'clock in the morning time. And according to the run rate around the world of these kinds of virtual meetings, the sods in Australia and the poor guys around this area of the globe get the short end of that stick. And quite frankly, no one wants to hear me at 3 in the morning, let alone the rest of this virtual working group. I think on the whole, because of that, and because of the wide diversity of participation in this working group, it's not a core of folk in this place or that place. This is going to actually favour some and really, really cut some others out. And if you start quoting back at us, well, we decided it in the virtual meeting, then, as someone who is probably not there, because like I said, you don't want to see or hear me at that time, this is not a good idea. I appreciate that slows things down, but nevertheless, trying to find a time that's acceptable for literally all around is incredibly challenging. And someone always loses. Oh, let's rotate them. Oh God, in my diary, having rotating meetings is about as bad as 3 in the morning. So let me gently counsel the chairs that this might not work for this particular widely dispersed set of participants. Thank you.
We understand your concern on another group that is similarly broad in the across the community, the RSWG. I have faced this, and this is why you confirm all the decisions on the mail list. But I understand your point and agree. So the agenda here is very full. So the first question is there any agenda bashes, like somebody who doesn't want to speak? No, I didn't think so. Okay, so the first thing we're going to do is go to the first presentation, which is on ASPA. Sriram.
Yes, this is Sriram. Hello, everyone. So I'm going to just give a brief update on the ASPA-based path verification. The status is we did a version bump up just for Keep Alive from 16 to 17. That was in February. But the real changes will appear in version 18. Currently, there is the editor copy which has the changes and it's in good shape. So we devoted a reasonable time and effort into it to get it into a good shape. We are waiting on one author who is taking another look at it, and then hoping that soon we'll upload the version 18 to the IETF. Next slide, please. So the changes that are coming in version 18, first of all, significant, number of places where we have improved the text for clarity and for removing redundancies. The security consideration section received some working group comments to make it more substantial, more balanced between what the procedures of ASPA accomplish for path verification and where there may be shortcomings. So that section is substantiated further to achieve a good balance there per comments received. One key change is it's normative. We say that this document updates RFC 9234. RFC 9234 is about the BGP roles and only to the customer OTC attribute. And that RFC is complementary to this document because this document focuses on route leaks that happened somewhere else in the path. But for route leaks that the local AS might initiate, RFC 9234 is where we need to go. So we are recommending the use of 9234 together with the procedures in this document. However, we have to say that there's a new BGP role, mutual transit, which was not included in 9234, but that is part of this document. And we simply have to say that because it is mutual transit, these two ASs, which are in that relationship, they can send any routes to each other. And therefore, they really do not need the RFC 9234 procedures on the mutual transit session between them. So that is one change. Next slide, please. So that's all about ASPA verification draft update. I just want to mention that we have a new with Job and Doug. I have a new draft on signed prefix list based route origin verification and operational considerations. Reason I wanted to mention it here is it does tie into ASPA also in some way. Because it turns out that the SPL or signed prefix list also complements ASPA in addition to 9234 RFC. This also complements in some ways protecting against AS forgery and reducing attack surface for forged origin prefix hijacks. So both of those ASPA also does, but only in the upstream direction. But the SPL is capable of doing mitigating these threats in general in any direction. So with that I close. We would welcome any comments on this draft on the mailing list. Thank you.
Any questions for Sri Ram? Okay, next presentation.
Signed prefix list. SIDROPS prefix list.
Testing 1, 2, 3. Okay. My name is Job Snijders, and I'm going to do 3 presentations in hopefully quick succession while we wait for the IT system. First one, signed prefix lists. Next slide, please. The purpose of a signed prefix list is to enable autonomous system holders to publish a list of prefixes they might originate. So the authorization is done through the AS identifiers, not through the prefix holders. This allows relying parties to conclude that when they receive a given BGP route and it originates from the same ASM as for which an SPL exists, but that route is or isn't included in the prefix list, they can make decisions like reject the route because it wasn't listed as something they might originate. This mechanism is intended to be complementary to existing ROA-based BGP prefix origin validation. It is not a replacement. It is an additional tool in the toolbox. Next slide, please. In terms of implementation status, an example object that conforms to the current profile specification is available. If you download the slides, you can click the blue word and it will bring you to the particular DER encoded object. So there's an object for validator implementers to play around with. Next slide, please. And I created experimental support for signed prefix list validation in RPKI client. So this means that CA developers can use the tool to see if they conform with the profile as defined at this point in time. Next slide, please. Next steps that I suggest for this working group, not only review the signed prefix list draft, but also review the independent submission by Sriram on how to use SPL objects in context of BGP. Another step in the process will be to do a draft proposal how to ship SPL information efficiently into routers, and then study what it takes to implement this in a BGP implementation and make use of it, and if there are interesting gotchas or good lessons learned during such an implementation phase. Next slide, please.
It's the last one.
All right. That gives me 2 extra minutes for the rest.
Any questions?
If you have questions or comments, send them to the mailing list, because today we have a packed agenda. RPKI validation reconsidered. This to me is the exciting talk. Next slide, please. Some terminology that may help us to reason about the topic at hand. There are 2 types of trust that are useful to think about in this context. There is assumed trust. This is the trust a relying party instills in the trust anchor. And compromise of this entity in which you instill trust is outside of the scope of the threat model. Then there is derived trust. Derived trust is what you calculate based on the thing you instilled your assumed trust in. Derived trust is calculated following specific rules. Rules that this working group sets. Next slide, please. That's way easier. So in other words, it is possible to define multiple validation algorithms for PKIs like the RPKI. Which algorithm is the correct one, or pure one, or valid one, or right one, is a matter of this group reasoning about what the outcomes are that we want. In my opinion, the current algorithm is problematic. It is defined in 2 places, and an implication of the current algorithm is that number resources that appear in extensions unrelated to the thing we are validating at hand can negatively impact the validation outcome of that entry. And in my mind, when this error condition occurs, the blast radius is too big. And this causes friction in inter-RER transfers, but also in transfers between LARs under the same RER. So some of the states you can arrive in with the current validation algorithm, in my mind, are disproportional to the objectives of what we're doing with the RPKI. So how does the current algorithm work? In the lower left, we have a ROA payload, 10/24, which must be contained in the issuer, the EE cert, which for demonstration purposes contains an additional entry, then the EE cert, both entries must be contained in that issuer, and all entries on the yellow CA must be contained in the resources subordinate to the CA in the green colored box. We contrast this with what I call the George-Jeff algorithm. In the George-Jeff algorithm. In the GG algorithm, you take the ROA payload entry, 10/24, you check if it's contained in the EE cert, you check if 10/24 is contained in the CA cert that issued that EE cert, and so on. So instead of roping in more and more resources as you go up the chain towards the trust anchor, you just look for a certification path specific to the resource you were validating, the one in the blue box. So let's step through some of the consequences of one algorithm versus the other algorithm. Here we have a layout. The green thing has one subordinate CA, and that subordinate CA issued 2 products, 2 EE certificates, 2 ROA payloads. With the current algorithm, if the green CA removes the 172.16/24 entry, all certification paths of all the subordinate products no longer are valid. And this is not ideal. If we contrast that with the GG algorithm, a very different outcome arrives. The ROA payload in the lower right bottom that no longer has a path towards the trust anchor because it was delisted in the green entity. And it's only delisted in the green entity in this example because in reality, the different components on this screen might be managed by different organizations, run on different timers. So this could be a very transient state that lasts a few hours, perhaps a few days. And to me, the desired outcome is that the ROA payload in the lower left, in the blue box, 10/24, which is utterly unrelated to 172.16/24, that ROA continues to be valid despite 172.16 being delisted somewhere higher up in the chain. I believe that this new algorithm is what we want. And an attempt has been made through RFC 8360, which was called Validation Reconsidered. It proposes that number resources unrelated to the VRP entry at hand are not considered in the validation algorithm. And this causes the blast radius to be precise. So if somebody higher up in the chain delists a specific resource, then all subordinate products contained within the resource that was being delisted, those should be invalid. Everything else should be valid. And this particular approach removes all friction around transfers. Unfortunately, 8360 is not deployable. It relies on the new OIDs being set by CAs. The text itself lacks the required definitions of the parameters for the 5280 way of extending validation algorithms. But adding more text to fill in what those parameters do and how you map the policies in different layers of the tree will not solve the core issue that it requires coordination and cooperation of all CAs and all relying parties. So if I'm grading this as homework, I'd say it is a great idea, but the execution plan is not feasible, C-. The path forward, in my mind, is quite simple. The RFC 8360 is deprecated. Its associated code points are tossed out because they serve no purpose. The draft that is behind this presentation proposed a surgery on various RFCs to insert the validation algorithm, the modern one. And all effort is going to be with the relying party implementation project. So at this point in time, that would be RP-STIR2, Fort, RPKI client, Routinator, RPKI prover, and that's a very manageable group in terms of effort. So if people want the new algorithm, I think now is the time to speak up and help this draft move along. So next steps for the group: review the draft that I would like this working group to adopt. For Team OpenBSD, it's going to be a bit of fiddling in RPKI clients to implement the new validation algorithm. Once we make progress on that, we'll share it with the group to allow other people to experiment with the new way of validating. And also with that, I would like to ask the chairs to consider starting a call for working group adoption for this specific RPKI validation update draft. End of this presentation slide deck. I think we have some time for questions.
We ran over on this one, but less on the other. Keep it to a minute.
This is the Kok right NCC because you asked for acknowledgement. First of all, this variation of this algorithm was very simple to implement. I've seen it in our old validator. And I think that this would really remove some problems that you can face with delegated CAs. Because if you one CA that's managed by the trust anchor, you can avoid many of these problems. But once you have independent entities, there's a real problem and it deserves our attention.
Rob Ostine, I'll try to keep it short. Yeah, we've been going around in this for a decade or more. The semantics, I completely agree this would have been a better way to do it if we had thought of it back in the day, right? No question there. The problem now is the RPs. You're talking about a flag day.
No.
I think you are, and that's what concerns me. We can have the argument later, but I think that's the part of this that concerns me. I don't see what to do without a flag day.
I think you're alluding to a desire for RPs from different implementations to behave in a deterministic way. But I would pose that we don't have that today anyway, because all the RPs have slightly different ways of doing things and verifying things. So I would be happy to talk more about this, but a flag day is not possible. This will just be a matter of RP implementations independently updating their implementations and releasing that to the general public.
Yeah, Tim Ruijs, NCC. I'll also try to keep it short. I think it's really valuable to discuss this again. So I would support an adoption call to have a structured discussion. I think an issue with the original proposal is that it would only be deployable if you follow the algorithm rollover, which is a much longer discussion. And I'll leave it at that. But I think there's value in limiting the blast radius. And as far as I can tell, there isn't a security concern with the resources that you no longer accept under this with this protocol, or this algorithm, I should say.
Thanks.
Ben Madison, Work Online. Just in
Final comments.
Not quite.
Real quick.
Just in response to Rob's point, the 8360 made it a flag day because of needing to change the policy OIDs, which is precisely why we've taken a different approach here. What we're suggesting that we do is interpret the existing policy differently at the relying party side, which can be done independently by different relying parties, without, as far as we can tell, any adverse impact for the transient window whilst the relying parties are behaving differently. That's precisely the reason for the updated approach.
I'll again keep it quick, Jeff Houston. The reason why I wrote this. Sorry?
I am berating the chairs for just letting the the queue fill up.
No, it got locked. It's down near the end. The reason why we wrote RFC 8360 was to actually solve this kind of problem of lockstepping. We were unaware of the way to do it in X509 world, and all of a sudden got assigned the new OID, and it's just kind of, this is never going to fly. Had we known that, as Rob Osteen said originally, had we known at the outset, we would never have done that validation algorithm, we would have done this one. Had we known there was a way to actually slide this one in with revisions and updates, we would have tried that. But by the time we got to publishing 8360 and it sort of came out with a new OID, we kind of got frustrated with all of this. And it's sort of, it's a better way of doing it, but we don't know how to get from here to there. You seem to be proposing a way from here to there. I support its adoption by the working group because I think it's a good thing to do.
Thank you.
Rüdiger Volk, I withdraw any concerns I may have raised on earlier cycles of this discussion. And for the Flag Day concerns, I think it might be a very good idea to explicitly state in the new ruling that CAs are advised to try to avoid the problem for a certain time that gives relying parties and their developers time for actually switching.
I am confident CAs are doing their utmost best to avoid this problem already today. There's no question about that.
Yeah, well, okay. I kind of actually putting a little bit more effort into thinking how to avoid stuff there, problems there, might actually improve.
Noted. Where's the thing?
Well, we're going to skip through and go to an FCBGP.
Yeah.
And then
Give
call you
me
back again.
2 minutes.
Then call you back.
Yeah.
But we don't have slides for that.
Yeah.
I uploaded them.
We're going to find them. That's why we're moving to the next one.
All right.
Thank you.
Thank you all.
FCBGP.
FCGB. Blah, blah, blah.
Eight minutes.
Hello, folks. I'm Zhou Tao from Tsinghua University. I'm going to have some updates for FCBGP. Didn't work anymore.
It should.
It worked yesterday.
You can't.
Okay.
Oh, it works right now. Okay. It works. So the problem scope of this thing is we have discussed FCBGP in Prague last year and also yesterday in IETF group. So some of the materials has been covered. So I would encourage people to read that on the video if I missed today. So let's first start with some design goals to keep everybody on the same page. So FCBGP is a secure routing protocol. It has the ability to secure both the control plane and data plane. We'll focus on control plane today. So it has two goals. The first goal, in full deployment, we hope that it can guarantee that any BGP path authenticated by our protocol is a secure path. That means it is infeasible for the adversary to claim a forged path to be secure, to be authenticated. In a partial deployment, we hope that FCBGP is compatible with the native BGP, but is incrementally deployable. That means it provides strictly positive security benefits in case of deployment. So the FCBGP is built upon a primitive called verifiable routing commitment or forwarding commitment, FC. So let's suppose an ASB receive a BGP update from its peer, A, for prefix P. So then the ASB will use the following forwarding commitment to publicly certify its routing intent over its next hop to the ASC. So the construction of the FC is simple. So the ASB basically saying, okay, I accept the route from ASA for prefix P, and then I would like to extend this path to my neighbor C. Basically, it assigns the entire stuff. As we can see from the construction, so FCBGP adopts a per pathlet validation scheme rather than a per path validation scheme like in BGPsec. So we believe this per pathlet validation scheme has two benefits. And the first is it has the same security guarantees as BGPsec in full deployment. And second, it is sort of like more compatible with the current BGP. So let me start with that's the recap. Let me start with some new stuff here. The first slide is how about the FC BGP pass attribute. So basically, we carry the FC in a new pass attribute defined here. So this new attribute is called FC BGP pass attribute. It is optional and transitive. And in each FC pass attribute includes a list of FCs. So each individual FC, the format is as follows. So it has 3 AS numbers basically to define the pathlet. And then it has the signing signature to verify the authenticity of this pathlet. So FC-BGP is compatible with native BGP. I'll skip this slide for the time of sake. And then we can start to discuss how the AS could process the FC-BGP basically. So the first step is need to extract this new pass attribute to check its authenticity, and then do the BGP pass selection. The verification of the FC itself is simple. Basically, you check the signature to verify the pathlet is consistent with the AS pass, basically. Here, I want to spend more time on the BGP pass selection part. So FC BGP is actually very conservative in terms of the BGP pass selection because the highest priority is still the local preference. So that means even if a pass that carries some FCs, but these FCs are invalid, but the AS may still end up using this pass if its local preference likes this pass. So basically, FC-BGP comes after local preference. So only if the local preference has a tiebreak, we move on to the secure pass selection. In this case, the AS. Oh.
Sorry.
Let's call 30 seconds. Let me do it. It's clear. So only if the local preference have the tiebreak, we move on to the secure pass selection. In this case, the AS should select secure pass over non-secure pass. For the secure pass, we actually have 2 subcategories. The first subcategory is the entire pass is fully authenticated, which means that for every single pathlet on the pass, there is a FC that is corresponding to certify this pathlet. And the second subcategory is called partial validation, partial pass validation. This is just a special case of the partial deployment, saying it's from our theory, saying that if in a pass there exists a sufficiently long subpath that is fully authenticated, then the entire pass is also fully secured, even if there are some legacy ASs that are behind this subpath. Remember that only this case counts for the partial validation. Other cases, like if the subpath is very short or the subpath does not from the origin, that does not account. So the reason we choose a very conservative path selection policy is we believe that the partial deployment will lasting for a long period of time. So it is difficult to ask everybody to upgrade their routers. So in that case, we want to make sure the FC-BGP is very less disruptive to the current routing. And due to the time of sake, I also do some very status update about the deployment status. So currently we built, and so the high-level strategy is still we want to only strategically deploy FC-BGP capable devices to avoid universal upgrade of all routers. So currently we build an overlay in China across multiple ASs to test its software functionality. Next step would be we're really deploying this FC-BGP capable prototype or devices to the network so that they can really propagate all the BGP update messages through the real network. So we encourage people to read our draft and also send me an email if we have any further discussions here. Thank you.
Go ahead, Rudiger.
Rüdiger Volk. Actually, I think you do not actually have to state new rules for path selection. I would actually take your supposed rules as suggestions for policy that may be used by operators.
Got you. Thank you.
Manifest.
Thank you. We're going to go to the next one.
Manifest. Thank you.
Manifest number handling. Tom?
All right, thank you. So this document is about what happens when manifest numbers become too large. So manifests were originally defined back in 2012, and the document that defined them set out that they have this field called manifest number. It needs to be incremented whenever a new manifest is issued, and that CAs and RPs shouldn't go past 20 octets for that field. Then in 2022, there was the manifest BIS document. It got much more prescriptive about the behavior here. In particular, it said that relying parties need to check when they retrieve a repository that the manifest has a higher manifest number. And if it doesn't, then that counts as a failed fetch and they fall back to the cached state if they have any. So this document came about because RPKR client implemented in accordance with 9286, and then there was further discussion with the route native developers about how they were going to handle it, and that in turn prompted this work. So a strict reading of the text in 9286 is that once you reach that largest manifest number value, because it's a bounded value, which is called MN max here, then the CA is effectively frozen. You can't make a new manifest that relying parties will actually download. So then the counter argument is, well, MN max is a very large number. Are you ever going to hit this problem? And that's a reasonable argument because it's a 20 octet number. It's huge. But you can set this value to an arbitrary value if you're the issuer. And in particular, Aaron have CAs that use huge manifest numbers that take up 1/128th of that space. I mean, there's still a lot of space there, but it's a huge value. And you could have bugs or corner cases or similar that mean that you're incrementing the manifest number by a large value or something like that. So it's at least possible in theory to hit this largest value. Now, if you're a subordinate CA, this isn't a big deal. You just do key rollover, get a new CA, and life goes on. But if you're a trust anchor, then you need to do a trust anchor key rollover, which is a bigger deal because you have to get a new towel, you have to get people to use the new towel, you have to deal with the long tail of people using the old towel, etc. So the draft has a strawman proposal for dealing with this, which is that if the manifest file name changes, then RPs should just skip the manifest number check. This is the current behavior in RPKR client. This document includes a detailed description of how RPKR client implements this. And that implementation is based on a reading of 9286 as being on a per manifest file name basis rather than a per CA basis, which is a reasonable interpretation of what 9286 requires. The pros of this are it's simple to implement, and if everybody agrees that this is what 9286 is actually saying, then nothing else is required. It's just an implementation consideration for people who are doing the updates. The cons are that 9286 could be interpreted as though this is not required or even permitted. In particular, if this is the interpretation of 9286, then it will be open to a CA to just use a new file name every time it issues a manifest and evade the manifest number check, which was presumably not intended. There's also RFC A488, which is RIPE's report of how the version 2 validator works, or worked rather, and that used a per CA basis for the manifest number check. There are other options here. None of them except do nothing is particularly good. The first one is remove the manifest number check. Of course, you get replay issues. The second one is make the largest manifest number a function of the current time. The problem with that is you have to contend with those existing Aaron CAs with large numbers. as well as potentially needing version updates to manifests, etc. There's serial number arithmetic, which is used in DNS to recycle the number space. Not really going to work here because you don't have visibility, don't have good visibility into what RPs have in this respect. And then the fourth option is do nothing. So then it becomes up to the CAs and TAs to do extra checks on their side to make sure that they're not going to cause any problems in this respect. This is what relying party support looks like for 9286 at the moment. So with manifest number reuse and regression, when it goes backwards, RPKR client rejects those manifests and the other validators accept them. With MNMax, the previous slides assume that MNMax has the largest value equal to the largest signed 160-bit integer. RPKR client implements 9286, but it interprets that, or its interpretation is that the largest manifest number value is an unsigned 160-bit number. So that's why there are tests here for MNMax and MNMax, what's called MNMax2, which is that unsigned value. So for Fort, it rejects MNMax and values larger than that. OctoRPKR accepts everything. RouteNator goes up to MNMax, but then rejects everything past that. And RPKR client goes up to MNMax2 and rejects everything past that. The reason those rows are yellow is it's not 100% clear what the correct interpretation is on that. So really the point of this table is that if we hit this value today, we wouldn't have any real problems. We'd just use a different manifest file name that would address the RPKR client issue, and none of the other validators are going to care if the manifest number goes backwards. So even if this draft doesn't go anywhere, hopefully the existing implementations can take this into account in their support for 9286. And that's it, if anybody has feedback.
Rob Austin, two things. One, I have a vague recollection, and maybe incorrect, that the manifest file name is basically GSKI.
Yep.
.mft, so it's determined by the SKI, so how are you going to change that? Secondly, the manifest was modeled very, very closely after CRL, so I suspect you have the same problem with CRLs.
Yep. With the file name, it does suggest that the GSKI be used for the file name, but you can use other file names. It's not supposed to reject it. Yeah, I didn't think to look at how CRLs handle this problem. But, yeah.
Ben, work online. CRLs do have exactly this problem. You don't run into quite the same bad side effect in the case of CRLs because they're used differently. I think the approach is basically the right one. I think that we need to have clarity on what the word file name actually means in this context. I think it's intended to mean in the case of rsync where you fetch the thing from, and in the case of RRDP, the XML URI attribute. I think that's the right way of thinking about file name in this context, and then it works in that sense. The fact that we're having this conversation at all means that there's enough ambiguity in the existing RFCs. I think that doing some surgery to the manifest definition is going to be necessary. I don't think we can really avoid it. But I think it's generally the right approach, and I agree that all of the other approaches that you enumerated are pretty bad in different ways. So I'm for this in general.
Thanks.
Okay, thank you.
Next one, enhancing route validation by aggregating validator. Aggregating. Yeah.
Hello, everyone. I'm Jia from Zhongguancun Laboratory. Today, I'm going to introduce our new draft on enhancing root origin validation by aggregating validated ROA payloads. In this draft, we have identified an issue with the registered ROA data and proposed a preliminary solution. Recently, there has been a significant progress on the registration and deployment of RPKI. However, still over 40,000 BGP routes are marked as invalid. It is clear that not all these are routing routing security incidents. We've noticed that certain routes that are marked as invalid or unknown, it is because that the aggregated parent prefix is announced, while only the pre-aggregation sub-prefixes has been registered. And this mismatch can mistakenly validate these routes as invalid. Both routing policies or incomplete registrations may lead to this issue. Okay, let's take a look at some examples. In this first example, due to route aggregation AS62915 has announced a parent prefix in this red route. However, it has only been authorized to originate 3 sub-prefixes across 3 ROAs. Only those 3 ROAs cannot validate this red route. And worse still, its upstream provider AS1404 has authorized to originate a more extensive range of prefixes. So this red route has been validated as invalid. But could it be valid? And in the second example, the path of the parent prefix in this red route serves as a backup path. However, AS7482 has only been authorized to originate 2 sub-prefixes. Although those 2 sub-prefixes could be aggregated into this parent prefix, this red route was still validated as invalid because of the ROAs from this AS17709. So in this case, could it be valid? Our answer is yes. Those BGP routes should be validated as valid, and the corresponding traffic should not be discarded. The primary reason is maybe the complex network routing policies such as route aggregation or traffic engineering or incomplete and inaccurate registrations. And this situation may occur when the address base holders are unaware of it when issuing ROAs. So our solution is to extend the original VRPs by generating aggregated VRPs to allow the parent prefix to be validated as valid. And we will take these 3 ROAs as an example to introduce our algorithm. Firstly, only contiguous prefix from the same AS with the same max length will be aggregated. And all the aggregatable VRPs will be aggregated into one single largest parent prefix, and other smaller parent prefix will be covered by this one. A quick question is whether the aggregated VRP is equivalent to the original ones. We will address this question from 3 perspectives. Firstly, for the reachability, yes, they are the same. And secondly, from the perspective of security, the answer is also yes. Announcing a parent prefix will not enable hijacking of any other additional traffic. However, for the usage of RV of the aggregated VRP should be different because the presence of the aggregated VRP does not necessarily mean that any other AS could not announce this prefix. So it could not validate the prefix from any other AS as invalid, just like the second update. So therefore, the route modification is required. And you can find our detailed solution in our draft. And today we just want to present this issue. And thank you, that's all I have. And since our draft has been just proposed and there may have been many issues we have not yet identified. So we humbly seek for comments or insights from the community. Thank you.
Hi, Jeffrey Haas. So while it is absolutely correct that more specifics are normally the way you hijack things, the presence of an unexpected less specific, if the more specifics can be caused to be blocked, is exactly the same problem. So while more specifics are the usual problem that ROAs help mitigate, if the provider decides that they don't want to do this, I agree with you, this is mostly misconfiguration when this happens, but if the provider had intended this to be present in the global table, they should issue the ROA.
Okay, thank you.
Job Snijders, Fastly. This work reminds me of work I did in 2019 together with Paulo Lucento on the traffic analyzer called PMACCT. Back then, I needed to prove to my management that deployment of RPKI origin validation would be safe to do in a global service provider network. So we needed to calculate how much traffic was actually destined for invalid prefixes. And what we came up with in the traffic analyzer engine is, in addition to not found, valid, invalid, a fourth state that was invalid but covered by not found or covered by valid. And we could classify the traffic based on that fourth state that is not documented in the RFCs. And in a way, we were doing the same approach as what is proposed here to see if there's aggregation opportunity and highlight that in statistics about where traffic is flowing and how that would impact the business. But ultimately, we concluded that for reactive traffic analyzing, it is very useful to consider aggregatable opportunities as sort of a separate state rather than just mark it invalid, because there still is a forwarding path, as you point out. But I agree with Jeffrey's comment that the moment somebody announces a route into the global routing table or the internet and it's invalid, for simplicity purposes, the universal reaction of neighboring networks should be to reject the route and ask the prefix holder to issue the appropriate ROAS to make the problem go away. And I fear that doing aggregation in the interpretation of the BGP routers will be an unwelcome complication where the consequences are hard to oversee. But I do appreciate the observation that not all invalids are equal, which I think is what you're pointing out. Thank you for your time.
Job, could you resend the slides?
Yeah.
Thank you.
Thank you.
Wait, no,
Oh,
Ben's
sorry.
going to answer.
So I can duck if you'd like the time back.
Yes.
Yes. Okay.
Thank you.
All right, thank you.
Thank you, Ben. Each and sign 7 minutes. Peering. Sign 7 minutes peering. Oh, no, sign. Yes,
That one?
That's Job's.
Oh,
We found it. Sign 7 minutes. Sign 7 minutes.
oh, I see. That one. There we go.
Okay, so today I'm going to introduce our proposal for signed subnet peering information object for deploying interdomain subnet. Li Chen, and I'm presenting on behalf of my co-authors. So first, let me give you some background on interdomain subnet. So attacks based on source address spoofing, such as reflected DDoS, continue to present significant challenges to internet security. And mitigating these attacks will require a source address validation. And there are existing mechanisms, but they all have problems in terms of validation accuracy and operational overhead in different scenarios, which we have pointed out in our problem statement draft in the subnet working group. And interdomain subnet proposes to exchange specific information among the ASs to solve the problems. And the specific information exchanging protocols, or what we call subnet protocols, have shown to achieve higher validation accuracy and lower operational overhead in our large-scale simulations. And the results we have presented in the last IETF meeting. So yeah, let's go into more details about how subnet protocol works. The main idea is twofold. The first, the origin AS will advertise its preferred AS path to the other ASs by subnet messages. And then the other ASs learn the incoming directions of the origin AS through received subnet messages. On the right, there's an example to see how subnet protocol works in action. First, we assume that the AS1, AS4 has already set up a subnet connection, and the AS1 will select the path 134. and 1564 to go to AS4. And the AS1 will send the corresponding subnet messages to tell AS4 the path. And the AS4 will learn that AS3 and AS6 are valid incoming directions for prefix 1, which is owned by AS1. And all the other neighbors are invalid incoming ASs for prefix 1. So the problem that we are trying to tackle here is actually in the first step, which is basically how AS1 and AS4 set up a connection in the first place. So let me go through the problem statement. So the key issue with the interdomain subnet for operators is incremental deployment. That is, the subnet protocol speaking agents within the subnet adopting ASs need to find and establish connections with other subnet agents. And currently the peering is assumed to be done manually by hand by the operators. And this is operationally and cognitively expensive, and there's a learning curve for the operators. And the most importantly, the problem is that there's no incentive for newly adopting ASs, and there's basically no turnkey benefits for enabling subnet as a feature, because the subnet peering must be negotiated one by one. So there are two potential solutions for automating the subnet peering. The first one is basically a gossiping, a flooding protocol. We all know that this will be bandwidth and computationally expensive. And the proposal that we are trying to present here is a public registry that contains all the ASs which have already deployed a subnet and are willing to set up subnet peering relationships, so that a newly adopting AS can use this registry as a reference and pick appropriate ASs to set up subnet connections. And we believe that RPKI is maybe the most suitable choice for this public registry, because it's already playing a central role in routing security, and the source address validation is a key aspect of routing security. So let me go into the details of how a SISP object will look like. First, we propose a content type, which this number currently is suggested, and we intend to go through the IANA registration process. And there are two important information will be contained in the e-content of the SISP object. The first one is the ASID field, which contains the AS number that has deployed subnet and can perform SAF on the data plane. And the second information is the IP address of the SAF agent of that AS, so that the other ASs can make subnet connections too. So in terms of validating the SISP object, the relying party must perform all the validation checks as specified in RFC 6488, as well as the following additional specific validation step of the SISP object. In the interest of time, I will not go into details, and please refer to our draft for the validation steps. And in terms of using the SISP object for routers, well, basically, the current draft is a bit hand-wavy in this part, and there's no specific algorithms, and we intend to improve that in the next iteration. But anyways, it will basically involve the three steps. Involves three steps. The first one is that we need to determine the closest AS to the AS that is deploying that is trying to enable the subnet function feature, and it will use the AS paths from the BGP announcements and the AS ASPA objects to determine the closest ASs. And secondly, it will use the SIPC object will be used to determine which of the AS have deployed subnet, and the peering candidates can be selected using multiple criteria, including existing peering policies, traffic volumes, and existing peering agreements. And thank you. And if there's any questions or comments, it will be welcome. Thank you.
Okay, thank you.
Thank you.
We're gonna, we have found the slides, so now we're gonna jump back to the previous slide.
How many minutes do I have?
What was the
6
minute?
minutes.
6. Okay, next up, a proposal for a new best current practices document to give guidance to operators to avoid signaling RPKI validation states in BGP path attributes. So over the last 12, 15 years, a lot of guidance, quote unquote, has been circulated where people with the best of intentions just sort of enumerated through, look at all the things you can do with the RPKI validation state, regardless of whether it's useful or perhaps even harmful. But here's an example from Cisco.com. Cisco people don't take this personal. It's just, you know, you have such a big website. Where the example is like, if the route is invalid, low local pref. If it's not found, a different local pref. And if it's valid, then it's super duper good, double the local pref. There's another example. There's a large transit provider that publicly documented that they associate specific BGP communities to specific validation states. And they claim that this has some use. And there's many, many more examples. But I set up a small experiment where I had a handful of prefixes, and using the illustrious crontab utility, every 8 hours, I would issue a ROA for one of those prefixes, and 4 hours later, revoke that ROA. And alongside it is a control prefix for which no ROAs are created or removed. It's in a steady state. And what you can see in the RIPE-RIS visualizer is that merely changing the fact that a ROA exists or doesn't exist somehow generates BGP updates somewhere. And I can assure you, it is not my test box, and it is not my provider. So somewhere down the path is reacting in some kind of way to ROAs blipping in and out of existence. And this is not good. Because at this point in time, almost 500,000 prefixes are covered by ROAs. And if there's some kind of unfortunate event, like the data center that hosts your validator slips out of existence, or your validator crashes, or there's an echo that's being rolled out and your routers can no longer reach your validators, or who knows what. Like, there's so many scenarios where you can lose view of the RPKI that means that if you associate a BGP community to the validation states, you need to regenerate BGP updates for perhaps 500,000 routes. This is another example of that churn. Recently, my employer issued ROAs for all its address space, and we did so with, you know, one push of the button. And we saw an incredible spike in BGP updates related to our resources. And this type of routing instability is not welcomed, at least not where I work. We even saw withdrawals somehow being created as a result of us issuing a ROA. So the expectation was, we're flipping all these routes from not found to valid, and we see withdrawals come out of the system. That is not what we wanted. So the recommendation in this draft BCP is to give operators guidance and say, operators should not signal validation states in transitive BGP path attributes. Specifically, network operators should not group BGP routes by their validation state in distinct BGP communities. And I think that having this reference out there will be helpful for people that create training materials and, you know, fly around and give workshops, or even for the vendors that tell you what you can do with RPKI origin validation knobs in your router. But I think it is in the best interest of the global routing system to clarify that putting the validation state in the BGP community is not a productive thing to do. Next steps, please review the draft. And chairs, I would like to call for working group adoption. All right. Questions?
Jared Mach, Akamai. There's a number of things that will actually cause a bunch of BGP churn, either in the in the local system. So for example, BMP stations, being disconnected and reconnected causes, a bunch of BGP events as well to happen as well. And I'm seeing a surprise face because it'll go in soft reconfig, route refresh all the BGP sessions, so it can dump everything to the BMP station. So it seems like there's a lot of related things here as well. I do think that this is a problem and we should be looking to address it. The only question I have is whether or not it's here or maybe grow.
Yeah, that's a fair question, and I hope the chairs will advise me on that.
Ben, work online. I absolutely agree with the observation, and the solution is right. I think there's an important caveat to call out, which is that there are still implementations of BGP speakers floating around where if you do not carry ROV state and extended communities in your IBGP.
Non-transitive extended communities.
These things do leak. And I think calling out the fact that there are implementations where they are unfortunately required and that they're still widely deployed on the internet and that some people are forced to use them, including ourselves, the onus is then on the operator to make sure that information doesn't leak and cause this kind of churn. But I think explicitly acknowledging that that exists and it needs to be constrained where it has to be used is a good idea.
Thanks.
Rüdiger Volk. Yeah, well, okay, kind of. I'm seeing two very different things. Causes for BGP churn and advisability of doing RPKI-based signaling. Kind of the churn, quite obviously, is something for IDR or GROW. And the signaling, the churn can be even caused by bad implementations on your edge if you just do internal communities, where we have to state, yes, if that churn actually transmits out, that's a bad implementation. We recognize actually avoiding the churn in that implementation takes some effort. The advisability of actually propagating RPKI-derived information in BGP in most cases runs into the problem that, well, okay, the BGP does not really make sure that you are that the authenticity of that signaling can be relied on. So kind of, yes, you can send out whatever you want, but you should not trust it if you get it from somewhere.
Thank you. We were really tight on time.
Luncheon. Oh, DEMA.
Yeah, but I don't know if it's
RPS. The reference implementation of how. Is there a reference implementation?
Okay. And we are super tight on time. So for the remaining four presentations, we won't be taking any comments. Go for it.
Well, IPsID2 was not listed in Tom Harrison's presentation. So Tom, IPsID2 is still active. Don't forget me. Don't forget IPsID2. So now I'm briefing what's going on with IPsID2. So why do we bother to do this? As we all know, the RPKI signed objects is related to one to another. Oh, sorry. Thank you, Jeff.
Lower it.
Yes.
Okay. So it's desirable for the RP to ascertain what is to be validated to during a transaction of incremental update from the perspective of the RP. So that's to say, the validation standards of one RPK some signed object is subject to change due to another one. By comprehending the characteristics of different RPK signed objects, the RP can use a method to find what they need in the RPK hierarchy. So therefore, some terminologies are defined to help us to do that. But please well know that all the thing we mentioned has nothing to do with the RPK signed objects stored in the hard drive. It's just in the memory. So here comes horizontal correlation. That is pretty straightforward. So ISOs with a semi-KI value are defined as horizontal correlation. And the union set of those correlations in the RPKI are therefore defined as horizontal correlation set. So if the validation standards of one ISO needs to be verified due to the update from another one in the same horizontal correlation, and then the former one is considered to be horizontally involved with the latter one. Okay. Oh, sorry to forget to mention the how we implement this with the mapping container to implement this with AKI as a key value to management this correlation set. Vertical correlation, well, a similar conception. An ISO and all its adjacent child ASOs is defined as vertical correlation and something like that. And I would like to put emphasis on why we put adjacent here. It sounds like redundant, but I would like to say the process, the RP establishes the vertical correlation for every resource certificate in the RPK. So that's the reason why I put emphasis on adjacent child ISOs here. Involvement correlation. So, based on what I mentioned or what we defined, we can tell an ISO is either horizontally involved or vertically involved with the other one. So we call this is involvement correlation. And the union set of this involvement correlation is called involvement correlation set. We all know that the involvement correlation set will be removed after every transaction of incremental update and the corresponding validation of the RPK signed objects.
1 minute warning.
Okay. So this is a procedure of the whole process. Upon incremental update, the RP create the HCS and VCS and do the and find the target object and construct the RCS. Do the validation, removing the RCS, and update the local cache, and waiting for the next incremental update. So that's the clarification. We are not bring any change to validation of the RPK in any sense. This is just about some states, hard states and soft states in the memory to help the RP to do something quickly. That's all.
Thank you.
Thank you.
You have 5 minutes.
Okay, hi everyone. I'm Lan Cheng from Tsinghua University. I'm going to introduce this new interdomain self solution. I submit this draft in SIDROPS because this solution uses ASPAR and ROAS to generate sub-filters. The primary design goal of source address validation is avoiding improper block while maintaining directionality, and existing sub-solutions such as EFP UIPF typically generate sub-allow list filter by using information related to customer coin. However, solely using an allow list may cause legitimate traffic to be blocked if this allow list fails to identify all prefixes belonging to the custom coin. Here we use an example to show the improper block problem of solely using an allow list. In this figure, we focus on ingress self-filtering on AS4, and in this figure, AS1 has two provider ASs. They are AS2 and AS3. And AS1 attaches no export to all prefixes announced to AS2. So in this case, AS4 will never receive rules for prefix P1 and P2 from its customer AS2. And then in this case, EFP UIPF on AS4 will have improper block problems. It will block legitimate data packets received from AS2 with source addresses in P1 and P2. And to achieve a more robust self-solution, exists some more recent self-solution additionally use ASPAR or ROAS related to the customer coin to generate self-filters. But when some ASPAR or ROAS related to the customer coin are missing, improper block will still exist. For example, in this figure, if AS1 doesn't have its ASPAR, AS4 will still have improper block problems. So how to perform more robust ingress self-filtering when some ASs don't have ASPARs? BiconSelf additionally generate a self-block list on an interface facing a customer or lateral peer AS. This block list should contain prefixes belonging to the provider coin. The provider coin of an AS is defined as the set of ASs an AS can reach by using only customer to provider links. It is because prefixes belonging to the provider coin should not be used as source addresses in data packets received from any customer or lateral peer ASs. And then we can use BGP update messages, ASPAR, and ROAS that are related to the provider coin to generate such block lists. And due to time limits, I will briefly introduce the procedure. We will first use BGP update and ASPARs to identify as many as ASs in the provider coin. And then we can use BGP updates and ROAS to identify prefixes belonging to those ASs. And then we can use this block list to perform self-filtering. It can block data packets received from customer or lateral peer ASs with source addresses covered in this block list. And it can provide immediate incremental benefits. Even if the generated block list doesn't include all prefixes in the protocol, it can still block some spoofing traffic while avoiding improper block. And in this example, we assume the product coin of AS4 includes AS6, AS7, and AS8. If AS4 can identify all prefixes belonging to the product coin, it can prevent the ASs in its custom coin from spoofing source addresses in the provider coin. But if it can only identify partial prefixes, it can still block some spoofing traffic from the custom coin and avoid improper block. But in practice, we suggest to use both allow list and block list filters together. It is because it's difficult for now to make sure that the allow list can cover all prefixes in the allow list, so block list is needed. And solely using block list may still have improper block, so use both allow list and block list together would be better. Okay, feedback. Welcome to my email.
You have to go fast. 4 minutes.
That's the next one.
Understanding ROA deployment. Understanding.
Thank you.
Okay, this is one of my research work about mirroring ROA deployment and mirroring manners. This work has been published in NDSS 2024, which is a conference supported by Internet Society. So we hope this work can motivate more network operators to deploy ROA in the future. We all know BGP hijacking is one of the most important threats to today's Internet. And Manners proposes 4 actions for network operators to improve BGP routing security. And Action 1 requires network operators to prevent the propagation of illegitimate BGP announcement from customer ASs. So network operators must check whether the announcements of their customer ASs are correct. And IR-based validation and RPKI-based validation can be used to achieve this function. And the ROA is more recommended in practice. So considering the current ROA deployment ratio reaches nearly 50%, so how about ROA deployment? This work aims to answer the following 3 questions. So to answer the first question about ROA deployment and network operators' compliance to Manners Action 1, we measure the prevalence of RPKI invalid prefixes that propagated through each AS. We download BGP data and collect AS relationship from public dataset, and we finally identify more than 1,000 ASs that have propagated RPKI invalid prefixes. And we further found that more than 60% of those non-stop ASs are not compliant to Manners Action 1. We also measure the percentage of different classes of interfaces that accept RPKI invalid prefixes. And we found different ASs may adopt different deployment strategies. We also present the first notification experiment to evaluate the impact of notification on ROA. But unfortunately, we found that none of this treatment can improve the remediation rate of ROA. So why are network operators not following Manners Action 1? To answer this question, we conduct a large-scale survey among network operators.
30 seconds, please summarize it.
Yeah, and we conclude the non-compliance is mainly due to economic reasons and technical reasons. Then we make a large-scale simulation to find the best deployment strategy. And finally, we found that ROA at provider interfaces can work better than ROA work at customer or peer interfaces. So we think network operators are suggested to first deploy ROA at provider interface, and then at customer interface, and then at lateral peer interfaces. We also provide some recommendations, including operation, guide, backup, purchasing, and some future research directions.
Thank you. Thank you so much.
Thank you.
Man. Thank you. Sorry about that. You're good. Thank you. Yeah. Man.
Yes, selective.
Man. 3 minutes. Man. 3 minutes. Go.
I can't find them.
Selective synchronization.
I don't see them.
Synchronization. RPKI to RPKI router.
That one?
No. Go up, go up, go up.
That one.
3 minutes.
Okay, hello everyone. I'm Yu from China Unicom. I will present these slides on behalf of the co-author. So my topic today is whether to synchronize the RPKI data that is not necessary by the network. Just to propose an example that with the rapidly development of the IPv6. So we think that many IPv6 only network will be appeared in the future, such as the New China Education and the Research Network named the FITI. Its end the construction will be, I think, the IPv6 only network. And the China Unicom, as one of the ISPs in China, is considering to deploy IPv6 only network in the future. So we think that in the IPv6 only network, as the figure described in the slides, we do not need to synchronize some RPK data, such as because the reason that we do not need the IPv4 RPK data to synchronize to BGP route validation, because we think maybe waste of the storage on routers, or maybe we need to induce some unnecessary transmission overhead, or maybe because the energy efficient reason. So we want to discussion in this working group that at present, the RPK data type include 4 types. The first one is IPv4 prefix. The second is the IPv6 prefix, and the route key and ASPA. So we think that maybe more and more RPK data in the future, such as in the RC 7909, and also as the sign prefix list, also AS coins, and so on and so forth in the, I think, in the draft in the SIDR OPS. So we just want to propose this use case that if we do not need we don't need the unnecessary data, so we need to require all types of the RPK data, and whether to synchronize the RPK data that is not required by the network. So we just think that maybe we can discussion in the mailing list. After the consensus of the working group, we may think that some optional solutions to have operators to select RPK data synchronized to it, such as the solution 1 extend the SNM to support filtering data by RPK data
Please
type.
summarize. Thank you.
Thank you.
Thank you.
Thank you.
Last one. Yang. Yang. It is already there.
Where is it?
It's already there, yeah.
Yeah. Got it.
This is Taiwan Lin from New H3C Technology. I behave my co-author to present YAN data models for RPKI to router protocol. This draft is about this document defined YAN data models for RPKI router protocol. 4 YAN data models are defined as following. RPKI root protocol YAN is about how to configure and manage RPKI router protocol on routers. BP Orange AS verification YAN is about how BP validate the original AS based on ROA. BP's second YAN is about how BP validate AS based on BP SEC path. BP AS path YAN is about how BP validate AS path of BP routers based on ASPA. The RPKI YAN contains 4 tables. The first table is about the cache server list table. The cache server list table contains connective parameters, session parameters, and session state and statistics. Also records received from a single cache server list. Another global tables as ROA tables, router key tables, ASPA tables. The ROA tables record IPv4 and IPv6 ROA, and the router key tables contain a record of router keys of PDO. ASPA tables contains IPv4 and IPv6 ASPA. BP Orange AS Young is about to validate Orange AS based on ROA. BP sec Young is about to validate BP sec path attribute as defined in RFC 18.2.5. BP ASPA Young is about how to validate the AS path of BP routers based on ASPA. Thanks.
Thank you.
Thank you.
Okay, this was a really, really full session. We'll try and get more time next time. In addition to that, expect a doodle about when we'll have a virtual interim. Thank you so much. Enjoy the rest of the meeting.
Ooh.
Got to come up with a better naming convention for this.
Man. I think what we should do is before next meeting, just make sure ordering it.
Yes, exactly. I don't know. I'll tell you what it is. Just the title on the slide didn't match the name in the agenda.
Oh my God. Sorry, boss.